Today we are going to be working on lesson 5.3.4, using variables to represent quantities in word problems. Make sure you have your title written and you have your book out and open to page 298. When you have that, you can play the video again. 5.3.4, how can I represent it? Using variables to represent quantities in word problems. Today you will continue to use the 5D process as you solve word problems. In this lesson, you will use a variable to represent the unknown value in the problem. Think of these questions as you work on the problems today. What is the problem asking? What is the relationship between the quantities involved? And how can I choose which part of the problem to represent with a variable? Problem 5.128 says Mai has 1 box of Choco Blasters candy, and Warren gave her 3 more pieces. Samara has 2 mini boxes of Choco Blasters and gave 6 pieces to Will. Now Mai and Samara have the same number of Choco Blasters. How many Choco Blasters are in a mini box? Assuming all mini boxes of Choco Blasters have the same number of pieces in them. Use the 5D process to solve this problem. So the first part of the 5D process is describe and draw. So in that I'm going to write down the things that I know. The first thing I know is Mai has 1 box and Warren gave her 3 more pieces. So Mai has 1 box plus 3 more pieces. I also know that Samara has 2 mini boxes and gave 6 pieces to Will, so she would have 6 less. Now Mai and Samara have the same number of Choco Blasters. So after they do both of those things, Maya and Samara's numbers should equal each other. So after that, I'm going to start with the table part of my 5D process. So I'm going to divide it into the 3 sections of define, do, and decide. You should be doing these same things in your notebook. So for this problem, the thing that we're defining is how many Choco Blasters are in a mini box. So that's the thing that we are going to be guessing. So underneath define, I'm going to write number of Choco Blasters in 1 box. Then for the do, I'm going to decide how many Mai has and how many Samara has. And then decide, are they equal? Okay, so what I'm going to start by doing is choosing a number to see how many Choco Blasters might be in a box. So let's start with an easy number like 5. So if I pick 5 for my number in my Choco Blaster box, if Mai has 1 box, she would have 5 plus 3 more because she gets 3 from Warren. I'm going to divide these so we can see. So Mai then would have 8, and Samara has 2 boxes, and she gets rid of 6. So she has 2 boxes, so that would be 2 times 5 minus 6 that she gives away, and that would equal 4. So my answer here would be no. So I'm going to have to try another number. I would like you to work on your own and pause the video and find out how many Choco Blasters are in each box. When you have the correct answer, you can press play again and see if your answer matches mine. I came to the answer that there are 9 Choco Blasters in each box. If there are 9 Choco Blasters in each box, Mai would end up with 9 plus 3 would be 12, and 2 times 9, because Samara has 2 boxes, take away 6 is 12, so yes, they are equal. So that brings us to our last part of the 5D process, which is declare. Remember, this needs to be written in a full sentence. In Declare, you write the answer to the question you were originally asked. And we were originally asked how many Choco Blasters are in a mini box. So my answer to this would be there are 9 Choco Blasters in one mini box. And that would be the end of my 5D process for this problem. The next problem is 5-129. Alan's team was working on a problem but did not have time to finish it. They also did not follow the teacher's directions for showing work in the Define section. Discuss with your team what information you can get from Alan's table below. So if you look at Alan's table below, it looks like we're finding length and width. And in the do, you have to double each side and add them together. And then we're trying to find the perimeter of 36. A says, is there enough information in Alan's table to finish this problem? Why or why not? So take a minute and write down an answer in your notebook. Your answer should be no, because you can't figure out how they got from 9 for the length to the width, from 3 for the length to the width of 9. For example, we don't know if they multiplied by 3 or added 6. B, what would you need to know in order to complete trial number 2? Please take a second and record your answer in your notebook. Pause the video and resume it when you have an answer written. The next problem is 5-130. Alan's teammate Scott was also working on problem 129, but he organized his table differently. As Scott explained his table to Alan, he used the pattern in the first 2 trials to represent the quantities in the third row with a variable x. So as you can see, he has more detail under his width. A says, how is it different from Alan's table? So please take a second and record your answer. Include more than just the width I mentioned. B, what does the X in the table represent? Please pause the video and record your answer. Hopefully you wrote that the letter X represents the length of the table, because you can see that X is written under length, so X is the length. In words, describe the relationship between the length and the width. So how does the length compare to the width? So take a second, write your answer, and then press play. The relationship between the length and the width is, to find the width, you take the length, so x, times 2 plus 3, and that will give you the width. That's the relationship between them. D, where did the expression x plus 2x plus 3 plus 2x plus 3 come from? Explain your thinking. Please pause the video and record your answer, and then I will show you my answer. Expression x plus 2x plus 3 plus 2x plus 3 comes from the perimeter, because I know on perimeter I have 2 lengths, so I have 2 lengths plus 2 widths of 2x plus 3, and I get that from the last row of my table, and I know that I have to add all of those together to get the perimeter. So that would be the equation using x as a variable for the perimeter of our rectangle. The next problem is 131. Izzy's team used a 5D table to solve a problem that involved consecutive integers. Consecutive integers are integers that follow each other on a number line. The numbers 1, 2, 3, 14, 15, 16, or -5, -4, -3 are all examples of consecutive integers. The table below shows part of their work on the problem. Copy the table and finish the problem. After you find a solution, apply Scott's idea from problem 5-130 to add a row that uses a variable to summarize the problem's process. So the first thing that I would like you to do is to pause the video, and I would like you to copy down exactly what's written here. When you have all of this written, then I would like you to play the video again. So the first part of the problem tells you to find a solution. So I know that 15 is too small and 20 is too large. And I know that I have to have each of my consecutive numbers add up to 57. So I think I'm going to try 19. So if my first number is 19, the next consecutive number is 19 plus 1. The next consecutive number is 19 plus 2. So then my three numbers I'll add together are 19 plus 20 plus 21. And that will equal 50. I'm sorry, 60. And 60 is still too small or too large. So then I know that I need to guess the next lower number. I see that this time it went down by 3, so if it reduces by another 3, I'll end up at my target number. So hopefully 18 works. So I have 18 plus 1 will give me the next consecutive number, 18 plus 2. Then I end up with 18 plus 19 plus 20, and that will equal a sum of 57, which is just right. So after I found the solution, it says apply Scott's idea from problem 130 to add a row that uses a variable to summarize the problem's process. So if I look back at problem 130, I see that I have x representing the first thing that we guess. So when I add another row here, I'm going to have my first number be represented by x. So if the first number is x, I know that the way I find the second number is to do x plus 1. And I know the way I find the third number is x plus 2. And then at the end, I needed to add all those numbers together. And that was under my do section. So what I need to do for this is do x plus 1 plus x plus 2, and that all needs to equal 57. So that's how I would show this using variables instead of just simply guessing and checking. Now I would like you to finish problem 132 on your own, and then after you finish 132 you can show your teacher and you can get the homework for tonight. Good luck!